Episode 1 of Separated at Birth was made 16 months ago after Perseverance discovered a rock that challenged scientific thinking about Jezero crater. Now Perseverance has made an even more disruptive discovery. On this episode of Mars Guy, Perseverance landed in February of 2021 next to a geologic terrain unit that would later be named Seitah, the Navajo word for amongst the sand. This is a fitting name for a place with a mixture of sand and rock that was recognized from orbital images as too hazardous to land on or even drive through. And it also was recognized to contain rocks with an unusual amount of the volcanic mineral olivine, like maybe 25% or more, way more than most volcanic rocks on Earth. Perseverance was able to make a toe dip into the Seitah terrain to investigate the olivine-rich rocks. What it found there would surprise the team. Here's Mars Guy for scale. There was indeed a lot of olivine in these rocks, but it appeared to have formed in an unexpected way in what's referred to as an olivine cumulate. This happens on Earth in a magma chamber deep underground where crystals of olivine form and then settle to the bottom because they're denser than all the other crystals that form in the magma. But Seitah rocks are at the bottom of a big crater, not in an underground magma chamber. So the explanation was that maybe there was a thick stack of lava flows or even a lava lake at least 100 meters deep. This would allow olivine crystals to settle to the bottom. Then a few billion years of erosion would remove the overlying lava to expose the olivine cumulate. This has become the published explanation, the scientific script for the olivine-rich rocks of Seitah. Then in July of 2022, Perseverance discovered a rounded boulder on the top of the Delta Fan deposit that probably washed in from outside of Jezero crater. I reported at the time how remarkably similar its texture is to the rocks of Seitah, as if it formed in the same way. We know from orbiting spectrometers that there are also lots of olivine-rich rocks outside of Jezero crater, so maybe this was one of them. But those rocks have been interpreted as deposits of explosive volcanic eruptions, not thick lava flows or lava lakes. Now the rocky ridge on the rim of Jezero crater, called Pico Turquino, is adding a new twist to the story. Perseverance drove around the back side and found a place with notably flat-lying rocks that could be safely investigated. It started by grinding a spot for the arm-mounted instruments to have a flat and relatively fresh surface to look at. The view from the Watson camera showed notably angular and irregularly shaped grains and some very dark ones. This is similar to what's seen in the rocks of Seitah. The images lit by blinking LED lights show crystals with prismatic glints, a characteristic of olivine that I presented in episode 119 in the boulder that looked to be separated at birth. So it appears that the rocks of Pico Turquino are also olivine-rich, like the rocks of Seitah. But it's the similarity between the outcrops here and there that's even more striking. The ones here display horizontal bands that seem to come and go across the ridge in a way that's not like typical sedimentary rocks with their much more continuous layers. This is also a description of the rocks in Seitah, where it was first thought that they were layered, but no variations in composition or texture were observed, something that's typical of olivine cumulate rocks on Earth. The horizontal banding does look a bit like that seen in some ignimbrite deposits on Earth. Here's Earth family for scale. This is the Chiricahua National Monument in Arizona. The rocks here formed from a cataclysmic volcanic eruption 25 million years ago that produced nearly molten ash particles that flowed out across the landscape before depositing and welding together from heat and pressure. The banding is referred to as foliation, which is an irregular layering that forms from some combination of flow and post-emplacement processes. the strange columns called hoodoos formed over time from erosion along vertical cooling joints. If the rocks of Pico Turquino are indeed comparable to those of Seitah, then they all may have formed from the same process, but were separated by erosion and maybe burial after they were born.